Hi guys. So this video is going to be on emissive textures. It's actually going to just be a lot on textures. We've covered how to make materials, and I've shown you how to add a texture. What I have here is a pretty basic scene. I've got a sphere, and then I created a sphere material that I didn't change anything to yet. So I just applied that to the sphere. There's nothing going on there. Since we're working with lighting and color, I turned this directional light basically off, but I'm going to crank it back up. Um, okay, so what I want to do is I want to show you how we can affect programmatically the color of the sphere. We're going to be doing this again this week, but in order to understand emissive materials, it's going to help if you understand a little bit about what's going on here. What we're going to do is basically just affect this material. And as I've talked about in class, a material really is just a shader program that's running. And we can, I believe, take a look at these shaders. I don't even remember how to get in there. Edit shader, that'll do it. So we can see what properties, basically these are just variables that we can affect. So if we want to change the color, the texture, any of these we can. We'll start by doing the color, and then we're also going to end up changing the emission color when we make this emissive. And all I mean by emissive is just it emits light. So let's start simply by, like I said, changing this through code rather than doing it here. So I'm going to leave it as white, and basically I'm going to attach a new script to my sphere, and it's just going to be called sphere. Let's do sphere matte change. Matte just short for material. And I'll open that up. Okay. I think I'm going to do real quick is I'm going to set this to the Visual Studio settings just because that's what I'm more familiar with. If I can remember where it is. Oh, it already is. Okay, well that's cool. Then if I do this, yeah, that's not working at all. Well, this is a great video, huh? Well, I guess I'm going to have to make do because I don't know where that setting was. And you don't really want to watch me do this for 5 hours. So, anyway, I guess I'm stuck with where we are. Okay, so the first thing I need to do is if I want to affect the material, I need to get an instance of the renderer. So we've used this a little bit in class just to turn off whether or not we can see something, but this is actually the component that keeps track of the shader. And by keeps track, I just mean kind of holds it. It has a variable that is the shader. That's not a great way of thinking about it, but I guess it'll do for today. So we get the renderer the same way we get our rigid body, our transforms, that kind of thing. So I'm going to create a private variable here called renderer. Actually, it's going to be a renderer. but I'm just going to call it rend. And like I said, we get it the same way we do using this get component. I have a new keyboard and I'm not used to it yet, so I apologize for the crappy typing. Get component of type renderer. I always forget I can't do that in mono. Okay. And then in the update, let's just change the color here real quick. I don't want to do it in the update because that's going to do it in every frame. So let's do a if input dot get mouse button down 0. Okay, so basically when we click, we're gonna change the color. So let's just change it to like red so we can see it work. So the way we do that is I have to get the material, which like I said is part of the renderer component. So rend.material, and there's a function called setColor right here, and basically what I have to do is I have to tell the shader what variable I'm trying to set and then give it a color. And so if we look back, I already know what it is, but if we look back here and I look at the shader, if I edit it, we can see that we want underscore color is our property that we want to change. And so in mono, I'm going to create a string called underscore try to color, and I believe this is case sensitive, so make sure it's an uppercase C, and we'll say color dot red. Okay, so now hopefully when we click our mouse we change the material to red. Let's build this. I didn't need to build it, just meant to save it. Okay, why are you opening a new instance of Unity? Alright, apparently I have some bugs to work out in my computer here, but hopefully that's saved and will allow me to run this. Okay, there we go. So I just clicked, it turned red. We are good to go. I'll show you one more time. Sphere's white, I click, there's red, we're good to go. Okay, so that in itself is kind of cool and useful. So we can dynamically change colors pretty easily. So I want to talk about this shader a little bit more. I'm going to kind of get some of these minimized so we can see it. We talked about the albedo. This is really just a texture, so I have in here kind of a metal texture somewhere. Probably just passed it. Yep. Whoops, that's the wrong place to apply it, but you get the idea. Right, so put it on the wrong texture. So let's try that again. Okay, so you can see this is kind of a scraped metal type texture, and so what we're going to do now is I'm going to actually digress real quick. This will still apply a color change to this. So if I click, I'm now getting a red sphere with that brushed metallic. So you can combine these two. Keep that in mind, because that's eventually what we're going to do with this emissive texture. So I want to talk about a few of these options in the shader, starting with normal map. So a normal map is kind of a special map that artists make. Sometimes you see these weirdly colored pictures that come with some of your standard assets. These are all normal maps, and basically what they are is the color kind of tells the light basically which way to reflect off to give it some 3D effect, I guess, for lack of better terminology. I'm going to apply this cliff normals here, and you can see it's kind of hard to see over the wireframe, but when I click on it And if I zoom in, as I move, see how the light kind of reflects and makes it look bumpy? You can really see it over here. It really looks like it's gouged pretty good. Um, so that's what a normal map is for, and it really only works if you use a normal map. So like if I bring up Chrome here and I do an image search for normal map, image search. There we go. So you're gonna see all of these are examples of normal maps, and you can usually tell pretty quick because it's like a light purplish color for the most part. This is the color for basically bounces straight back, doesn't have any groove or anything. So normal maps are kind of cool. Next and last one we're going to talk about today is an emission map or emissive map. And basically what this is this is what part of this emits light and what color light and how bright is it. And so what an emission map looks like is basically a black and white grayscale image. I have one that is strictly black and white, and basically what's going to happen is anywhere that there is black on it will emit no light, and anywhere that's white will affect light. I did it again. Click the right object. Alright, let's try it again. So, alright, so you can see here that I've got, I'm going to turn this off. That I've got basically a white strip that's now emitting light. Where the image is black, it's just kind of the normal texture we had underneath. And I can turn down how bright that light is, and we can still see the texture underneath it if I turn this down enough. So, you could have something pulsing or something like that. I want to kind of stress here too that if I go up, I can go past 1, and if you do that, you'll see this HDR. That stands for high dynamic range. And the way that I explain this is if I asked you what color the sun is, you'd probably say yellow. And if I said, okay, what color is a sheet of paper? Most paper is white, so you'd probably say white. And then I would say, okay, what color is brighter, white or yellow? And the answer is white, right? Because white is brighter than yellow. White is all the colors, yellow is just a fraction of the color spectrum. But if I were to say, what is brighter, the paper or the sun? Obviously, the sun is much, much, much brighter than any light reflecting off of paper. So this high dynamic range is basically saying like how bright is it beyond like our normal spectrum that we can see, or even not even see, but just you know based on standard color, is it brighter than that? And the sun, obviously, even though we're getting kind of a yellow tint, is much brighter. So what I can do, for example, is I could set this to a yellow. It's kind of an ugly yellow, but it'll work. Um, Something like that, maybe. And then I can kick up the HDR really high. And essentially this is becoming like the sun. And you can see it's actually turning white. But what'll happen is it'll kind of glow a yellowish color too. Now the reason we're not seeing any of that is because emissive materials only work on static objects. That means objects that are not going to move in the scene. It takes too much time to bake these colors, and so if things are moving around, it would just kill your refresh rate on your game. So the way we mark this as static is I want to mark not only what object is emitting the light, but also the things around it that I want to kind of reflect the light. So in this case, it's really just going to be my sphere, and then the plane that it's on should also get that. And as you can see right off the bat, I'm getting a really nice looking yellow light around it. So again, because I've got the HDR kicked up, the light directly that you're looking at looks white, but the light bouncing off looks more yellow. And so I can kick that up even more, and go really bright and come back down, and you can kind of see how now it's turning more of a yellow color as I get closer to 1. Um, and so what we'll do now is I'm gonna make it like a cool, I don't know, purple blue. I did purple last semester. Let's do like a blue color. That'll look neat. Okay, so again, I'm in HDR. What we'll do is we'll affect, you know what, I'm gonna leave it at like a yellowish color, and we'll turn it to blue through code when we click, and then we'll make it kind of, we'll make the intensity kind of pulse. That'll look neat. So I'm gonna jump back over to my script here, and rather than the color, I want the I gotta think about what it is here. The emission color, I think. I'm almost positive that that's right. So we'll set the emission color to blue, and then we'll make that pulse in a second, but let's make sure it's the emission color before I get too far. So if we run it, it should be yellow. If I click, it should be blue. Okay, so looks good. And back into my script here. Okay, so let's make it pulse, and I tend to use a sine wave a lot of times to make things kind of pulse back and forth. It gives you kind of a smooth transition rather than just kind of going back and forth. So if you're not exactly a math whiz, it's not a big deal. You can just kind of copy and paste my script. So I'm going to create some public variables here. I'm going to keep them private actually. And let's make a float called min. And I'm just going to say that that's 2. I'm going to have to mess with these ranges, but private float max. This is going to kind of be the range that they kind of bounce between. Like I said, I'm not sure. And then we're going to need one to basically keep track of the time and kind of step between these. So one more, private float step. That's going to equal 0.1. Let's do smaller than that. Let's go like 5. Okay, so that's what we need for variables. And I'm going to get rid of this mouse button down part. And what we're going to do is go amount equals min. Might help if I spell amount right. And you know, we need one more variable to keep track of where we're at time-wise. So private float value equals 0. And we're going to want some of these in the inspector. So I apologize if you can hear my desk squeaking. It's kind of coming, some of the bolts are coming loose. Okay, so those can stay out of the inspector. These two down here. Those are the ones we're going to want. So this is kind of the speed at which it's going to pulse back and forth. This is how kind of dim it's going to get. This is how bright it's going to get. And like I said multiple times already, I'm going to have to play with these as we run it, because I don't have any clue what that's going to look like right now. So in here, we're going to say value plus equals our step variable. And we're going to say that we're going to create a variable for the sine. So float sine equals, I'm going to use the mathf library, dot sine of the value And so sine mathematically is between 1 and -1, and I really just want it to be between 0 and 1. So the way I do that is I add 1 and divide by 2. So I'm going to say that sine is equal to sine plus 1 divided by 2. Now that's going to try to do 1 divided by 2 first, so I need some parentheses here. And then we'll do amount plus equals the sine times the range, which is going to be my max minus my min. Okay, and then what we'll do is we're going to say that the color, rather than just being color.blue, say that color equals color.blue times the amount. So basically, if you multiply a color times an amount, this is that kind of range slider we were using before, the amount of brightness, more or less. And then I'll use this color variable here. Okay, so let's try that out. I have no idea what this is going to look like, so all we can do is give it a go. So it's yellow now, but when I run it, it should actually start pulsing blue like almost instantly. And we do have blue. I forgot one thing. So basically what happens is since the emissive material changed, we're losing basically the lighting that's coming from it. And what we have to do is we basically have to say like, hey, world, this lighting changed, so update it. So we just need one more line in our code, and that line is that we need to tell there's something called the dynamic GI. GI just stands for global illumination, and that's basically Unity's lighting engine. And so if we say dynamic GI dot set emissive, I believe. Yep, and we give it the renderer, which we have, and our new color, which is just color. So now, let's see what this looks like. Alright, so we've got our lighting updating, but I'm thinking that it's not really that visible, so maybe I'll kick this way up. Alright, sure doesn't look like it's working. Tell you what, I'm going to pause the video and play with it a little bit and figure out why it's not working. Okay, I'm back. I figured it out. It was a silly little typo. I had a plus here. So we were getting basically a 1, or somewhere between 0 and 1, some really small number, plus, and this ends up being about 10 or 8. So we were getting 1 plus 8, and our value was always around 9. Now it's going to be 1 times 8, or 0 times 8, or whatever. So I just changed this to a times rather than a plus. So easy fix, but easy one to miss too. So here's our final effect. As we get our blue, and we've got our emissive texture pulsing, and we can zoom around and take a peek. If we look in our scene here. And so, yeah, that's how you create an emissive texture. I'll see you guys on Wednesday.